This is a video looking at electric current for Module 4, Electricity and Magnetism of the Year 11 Physics course. So electric current is quite a simple concept to describe. It's something that you're probably familiar with from junior science. So current, by definition, is just another way of saying the flow of charged particles. Okay, typically electrons. Now, mathematically, it's quite a simple concept. So here's the formula for current, I for current in physics. Current is defined as the amount of charge, Q, passing in a certain time, T. So Q divided by T. Q is charge measured in coulombs, units of coulomb, capital C. And time T, measured in seconds. Okay, SI units for time are seconds. So therefore, current has units of coulomb per second, which is just amps. Okay, amperes. So very simple concept. Let's do an example using this formula. So let's suppose we have a cell membrane, an application of this formula to biochemistry. So a cell membrane, so here's a cell. Okay, animal cells, we're made of animal cells. Cell's got a nucleus at the center. Cell membrane's like the wall. Okay, it controls what comes in and out of the cell. A cell membrane has 500 calcium ions, CO2 plus, moving across it in 1 second. What's the current flowing through it? Let's break this down. So we need to use this formula. I equals to Q over T. We know what T is. T is just 1, right? T is just 1 second. Now Q, what's Q? Well, calcium ions, so calcium in this case has a positive charge, calcium ion of +2. So therefore Q is 2 times the charge, 1.6 times 10 to the minus 19. Okay, so the charge of a positive, so an electron has a charge of minus 1.6 times 10 to the minus 19 joules. The positive, a positive version of that is just 1.6 times 10 to the minus 19 joules. And then we'll multiply that by 500 because there's 500 of those ions, right? So that's Q. So we have all we need. So we just substitute. So I is equal to 2 times 1.6 times 10 to the minus 19 times 500 divided by 1. Work that out, you get around 1.6 times 10 to the minus 16 amps, right? Just a sanity check. 10 to the minus 16, yeah, it makes sense because we're talking about very small particles in this case, the ions, okay, and cells are very small as well. So that's how we use it. Just a note as well. So electron current. Okay, electron current versus conventional current. So electron current flows from the negative terminal. Suppose we have a battery here. Okay, hooked up to, say, a wire. Electrons flow from the negative terminal to the positive terminal, okay, in this direction. Whereas conventional current, okay, or simply current, behaves as if positive charge carriers cause current flow. In other words, it flows in the other direction. And so if you think of copper wire, if you zoom into a copper wire, you will see metallic bonding taking place, okay? Metals bond via metallic bonding. What does that mean? Well, the nuclei of any atom, the nucleus of any atom is positive, right? Electrons are free to flow in a metal. Okay, that's a copper wire. They're free to flow. These are called delocalized electrons. Think of your local supermarket. That means it's nearby. Delocalized, on the other hand, means it's not not restrained in any way. It's free to flow. So the electrons are shared amongst the positive nuclei, positive nuclei, lattice of nuclei. And so electrons flow one way and the positive nuclei can be thought of as flowing the other way.